without further delay, we just have to start the session. So in the lecture 3, we have some numericals left in the previous session. So first we're going to do that. Then after that we're going to come here. Okay. So what are the numericals here? I have already shared the questions with you guys. So this is the first one. In these cases, I have already told you, you just have to clear the fraction. This was the last part that was left. So just a second. Only the last part left. So how to do this? How to clear the fraction? The same thing you are going to do 1/3. That is going to be 0.33. Okay, and this one will be also 0.33, and 0.67 divided by 2 is over 6 is कर देंगे तो nearly it will be 0.33. Okay, so in this way it will be 1 1 1. Okay, so this will be the clear answer. Okay, so how to do this type of questions? You just have to get the other dimensions from the rutile crystal. Okay, rutile crystal crystallized into eternal crystal system, and from that eternal crystal system you have to find out what is the relationship between the crystallographic axis. In these cases it is a1 is equal to a2 is not equal to c. So a1 is already given, so you have two axes, that is your a1 and a2. Okay, simply the horizontal, ये b आपका क्या convert हो जाएगा a2 में. ठीक है, this is your a1 and a2. Okay, so in this way you can easily do this type of questions. Just remember about the crystal. If something is missing, if you are thinking that something is missing, then you can easily find out in the question that there's some additional data, and from that additional data you can easily you can easily correlate all the things. Okay, and this is what it is given. What are the Miller indices of a plane that intersect each crystallographic axis at 6 angstrom? Okay, then axial intercept कितना हो जाएगा? Axial intercept कितना हो जाएगा? It will be 6 angstrom. ठीक है, IB will be 6 angstrom, AC will be 6 angstrom. Okay, मतलब if there is a plane like that, ठीक है, ये प्लेन अगर मान लेते कि एक प्लेन है, तो ये A crystallographic axis को B और C को सेम ही डिस्टेंस में काट करता है. That will be 6 angstrom. Okay, so just a second. And assume a primitive universal dimension, मतलब universal dimension already given along the A axis, that is 2 angstrom, B axis that is 6 angstrom, C axis that is 3 angstrom. Okay, तो what we basically do, हम क्या करते हैं पहले तो एक्सेल रेशियो निकालते हैं. ठीक है, तो एक्सेल रेशियो केसेस में A is given as 2 angstrom, B is given as 6 angstrom, C is given as 3 angstrom. Okay, तो एक्सेल रेशियो हम जब निकालते हैं, हम क्या करते हैं, हम सबको B से डिवाइड कर देते हैं. तो 2/6, 6/6, 3/6. Okay, so what will be the axial ratio? तो 1/3, 1, 1/2. ठीक है, this is your axial ratio. इसको अगर और भी सिंप्लीफाई कर देंगे तो 1/3 will be 0.33, 1 0.5. Okay, 1/2 will be 0.5. Okay, these are the axial ratios we are going to use in order to determine the Miller indices for that plane which is going to intercept each crystallographic axis XYZ at 6 angstrom distance. Okay, so what is the formula for the Miller indices HKL? That is your axial ratio by axial intercept. Okay, so what is the Miller indices HKL? That will be axial ratios, that means 0.33 divided by 6 angstrom. Okay, then this will be 1/6. This is 0.5/6. Okay, is it clear? Otherwise, simply you can also write 1/3 divided by 6, 1/6, 1/2 divided by 6. Okay, so it will be 1/18, 1/6, 1/12. Okay, then what amount we are going to multiply by which this will be clear, the fraction will be clear. Just take the 6 करेंगे, 3 करके देखते हैं. That will be 6, 2 and 4. Then again we can 2, 3, 1, 2. So 36. 36 we are going to multiply, by which the fractions will be cleared. Okay, 36 we are going to multiply, so that will be 2, 6, 3. Okay, this will be your Miller indices. Okay, this will be your answer. Okay, so you guys are getting what I'm trying to tell you. Okay, so this is a modified question. It is already asked in GATE 2020. So just the most important thing in questions is that just try to extract the data. तो आपको अगर डाटा मिल गया ना कि ये इसका मीनिंग क्या है उसका मीनिंग क्या है, then you can easily fit those data into the formula and finally you will get your answer. Okay, okay. So these two questions I think left in the previous class. So now we are going to move on. This one is also one important one. Okay, just try to do. I also ये आपको मैंने दिया था √1/√3. ठीक है, तो ये कितना हो जाएगा? Cos inverse √1/√3. Okay, so you can easily find out the answer. And remember, whenever we are doing any calculations, okay, any numericals, that it is both for the IIT JAM and GATE students, always use the GATE calculator. ओके, तो आपको लोग कि सर कहाँ से लाएंगे गेट कैलकुलेटर? देयर इज एन एप्लीकेशन. ओके, गो टू द गूगल प्ले स्टोर. ओके, तो वहां पे जाके सर्च करना कि गेट कैलकुलेटर. So you will get that application, and whenever you are doing any numericals, just try to put those data into the gate calculator, by which it will be habitual for you guys to use that calculator because it is little bit different from the normal calculator. Okay, so now we are going to move to our new session. Okay, so in module 3 there is point group, space groups. Okay, so remember the GPP. Okay, GPP means Geodost practice problems. As I have told you earlier, it is going to released after the end of the crystallography. मतलब only 1 or 2 classes will be required to complete all the things. One class I think. So that will be required to complete all the numericals. Then after that, this GPB of crystallography is going to be released. In that, there will be 70 to 100 questions will be there. Okay, along their solutions. So that will be much more easier for you guys to revise all type of questions. Okay, okay. So now I am going to start the module 3. So we have lesser time today because I was already delayed. Okay, okay. So point group. So first thing before coming to the point group, we have already left the point symmetry. तो point symmetry वाला भी पार्ट हमारा थोड़ा बच गया था. ठीक है, तो point symmetry को पहले कर लेते हैं, देन उसके बाद हम उसको शुरू करेंगे. हाँ, point symmetry part. So what is the symmetry? If you have guys remember, so let me just start from the basics. So we have already seen this symmetry. Symmetry means there is a proper definition of the symmetry, but it basically the arrangement of the motifs. Okay, there is a pattern. Okay, so it may be translational, or it may be point symmetry. Okay, but point symmetry is about a point, and translational symmetry is about a volume. Okay. Okay, so now we are going to see the point symmetry. So what it is basically going to tell you, it is going to tell you that there is repetition of motifs is basically going to create a pattern. Okay, and those motifs are going to repeat it around a point. So this is the definition of the point symmetry. That means around a point it is going to repeat it. Okay, and there is various operations in point symmetry. Let me write for you operations and operators. Those who are going to operate those operations, they are called as operators. Okay, okay, okay. Operations केसेस में तुम्हारा आ जाएगा पहले reflection, then rotation. These three things you guys already know from your previous studies, but let me just revise all the things before starting into the point symmetry. Okay, so reflection, rotation, inversion. Okay, so in case of the reflection, what is the operator? This will be your mirror plane. Okay, mirror plane is going to operate the reflection of operation. Okay, rotation cases में it will be your axis. Okay, two axis of symmetry, three axis of symmetry. Simply axis of symmetry you can also write. Okay, so inversion cases में center of symmetry. Okay, center of the crystal, or you can say center of the symmetry. And these three things are going to create what? These three things are going to create what? point symmetry. Okay, three operations are there in case of the point symmetry, and by using those three operations you can easily do any type of symmetry calculations. Okay, any type of symmetry operations also. Okay, let me just start from the. Okay, so actually why there is rotor inversion not here, because the thing is that these are the operations. Okay, so first we are going to do the rotation, that is one operation. Then we are going to do the same operation in that symmetry. We are going to see those things, but just try to remember. First we are going to do the rotation, then after that we are going to perform the inversion operation on that symmetry. So that's why it is a combined one. So it is the rotor inversion, it is the different one. But these are the basics ones. Okay, on which the most of the symmetries are going to rely. Okay, okay. Now come to the reflection. तो रिफ्लेक्शन केसेस में तो वी आर गोइंग टू सी सिंपली इसको हम क्या बोलते हैं, रिफ्लेक्शन को इसको हम बोलते हैं प्लेन ऑफ सिमेट्री, because the operator is your plane of symmetry, because the operator is your mirror plane. Okay, so that is a plane. So plane of symmetry it is also called as, and the operator I have already told you that is the mirror plane, and we basically denote the mirror plane in small m. Okay, if there is a presence of any mirror plane in this symmetry, then it will be represented as small n. Okay, okay. So we're going to see a simple thing. Then after that, some example. Then we're going to leave, as it is a numerical classes. So we're not going to too much detail. Okay, okay. So what happens here in case of the mirror plane? If there is a circle, अगर मान लो तो there is a circle. Okay, there is a circle. So in these cases, what happens? A mirror plane passes through. अगर मान लो कि यहाँ पे एक mirror plane pass किया. This is a mirror plane. Let it denoted with the small m. Okay. So what happens? The patterns in one side. Okay, it will be reflected. Okay, get my point? The pattern on one side is a mirror image of pattern of a other side. ठीक है. Okay, so there is two types of thing in case of the reflection and in case of the inversion. Okay, there is a distance called same perpendicular distance. Okay, and in case of the inversion cases में क्या होता है, inversion cases में same equivalent distance. ठीक है, तो ये थोड़ा सा याद रखना. तो रिफ्लेक्शन कहा लिखे, हाँ रिफ्लेक्शन केसेस में क्या होता है, सेम परपेंडिकुलर डिस्टेंस. ओके, जैसे कि मैंने बताया कि ये दिस इज ए प्लेन. ओके, दिस इज ए प्लेन. ओके, वन साइड में अगर यहाँ पे ए लिखा हुआ है, इट विल बी ऑल्सो गोइंग टू बी रिटन एज ए. तो इसका मीनिंग ये है, ये जो डिस्टेंस में ये कवर करेगा, द डिस्टेंस फ्रॉम द मिरर प्लेन टू द ऑब्जेक्ट is going to be reflected at the same distance. Okay, and this will be your perpendicular distance. Okay, getting my point? The same perpendicular distance is going to be maintained during the reflection operation in the symmetry elements. Getting my point? If any object is there, तो वहां से जितना डिस्टेंस यहाँ पे होगा फ्रॉम द मिरर प्लेन टू द ऑब्जेक्ट, द सेम डिस्टेंस इज गोइंग टू बी रिफ्लेक्टेड from the mirror plane towards the opposite side. Okay, so that is the main thing in case of the reflection. But in case of the inversion, we are going to see those things. Okay, तो वहां पे क्या होता है कि इक्वल डिस्टेंस मेंटेन होता है, वहां पे परपेंडिकुलर नहीं. जैसे कि अगर आप वहां पे, मैं उस टाइम में आपको बताऊंगा, बट अभी थोड़ा सा रिफ्लेक्शन को देख लो. हाँ, तो रिफ्लेक्शन केसेस में तो वी हैव ऑलरेडी सीन दिस सर्कल. तो सर्कल में कितना रिफ्लेक्शन, कितना प्लेन ऑफ सिमेट्री हो सकता है, सर्कल केसेस में कितना हो सकता है, यहाँ पे कितना है, देयर इज वन मिरर प्लेन. ओके, ये रेड आपका है, दिस इज वन मिरर प्लेन. तो इन केस ऑफ द स्फीयर, इंफिनिटी नंबर ऑफ मिरर प्लेन्स. ओके, उसका मतलब ऐसे काटो वो भी हाफ हो जाएगा, ऐसे भी काटो हाफ हो जाएगा, ऐसे भी काटो, सॉरी सेंटर के थ्रू जाना चाहिए. ठीक है, तो ऐसे भी काटो हाफ हो जाएगा, तो फिर ऐसे काटो हाफ हो जाएगा. दैट मीन्स it is going to be cut, or you can say it is going to be cut equal halves in infinity times. Okay, or you can say infinity ways में हम इसको काट सकते हैं. ठीक है, and there is another also, you can say the same equivalent distance from any object. if you are going to choose any object, अगर मान लो कि मैं ये nail को ये करता हूँ, तो this is going to be same distance, same perpendicular distance. Okay, so now here in these cases, so what is going to be happen? So in these cases, this is a butterfly. So in these cases, there is only one mirror plane. If you are going to see, sir, अगर हम ऐसे काटेंगे, so it is not going to give. You can see it is a different one, but it should be here also, but it is not like that. So there will be only one mirror plane in case of the butterfly, and this same cases also there is one mirror plane. Okay, so that is basically your plane of symmetry. Okay, so I'm not going to too much detail. Now come to the rotation. तो rotation cases में क्या होता है? तो what is the operator? The operator is basically your axis. Okay, और हम उसको क्या बोलते हैं? Axis of symmetry. Okay, axis of symmetry. तो axis of हाँ, यहाँ पे ये cases में थोड़ा सा आइडिया लगाओ कि what are the numbers of mirror planes in a cube? In a rectangular, पहले rectangular देख लेते हैं. How many mirror planes are possible in rectangular? Rectangle cases में कितना possible है? Let me just, that will be 2. कैसे होगा? देखो, first thing is that rectangle cases में ये थोड़ा सा इसको बड़ा कर देते हैं. Okay, so in these cases, what is going to be happen? So we are going to see. तो कैसे होगा पहला वाला? तो it will be like this, okay, equal half, and it will be like this, equal halves. Okay, but if anybody is going to tell that कि सर यहाँ पे भी तो हो सकता है, यहाँ पे भी तो हो सकता है, हाँ, if anybody is going to ask that कि ये केसेस में तो हो सकता है equal half में, but it is not the perpendicular distance. If you are going to see this distance, अगर मान लेते हैं कि 1 है, 1 unit, this distance will be 4 unit. ठीक है, 4 units. So it is not the perpendicular distance, equal perpendicular distance in the both side of the mirror plane. So that's why this is not going to satisfy the criteria of the mirror plane. In the same cases also, in this cases also, there is no mirror plane. Okay, only 2 mirror planes, which is like that. जैसे कि हमने अभी अभी इसे बनाया है, there will be 2 mirror planes. Okay, so in this way you just have to think about all the things कि कितना mirror planes यहाँ पे हो सकते हैं. Okay, so now come to the axis of symmetry. तो axis of symmetry cases में क्या होगा? The repetition of motifs by a set of uniform rotation about an axis. Okay, इसका denotation क्या होता है? It is going to be denoted as capital A. Okay, capital A means if you are going to talk about one fold axis of symmetry, axis of symmetry, then what it will be? It will be A1. Okay, so like that there will be A2, A3, A4, A6. Okay, so these are the axes, and if you are going to see also, so A1 will be your object, A2 basically your lenses, A3 that is your 3-4 rotational axis, it is going to, the example will be equilateral triangle. Okay, and in case of the 4-fold that will be square, and all the things you guys already know about it. Okay, so these are the things, and if you're going to see also, so this is a A1. तो एक्चुअली इसका मीनिंग क्या है? एक्सिस ऑफ सिमेट्री का मीनिंग ये है कि हमको सिंपली उसका एंगल जो हम निकालते हैं, इट इज बेसिकली 2 पाई बाय द n. Okay, n means, so it is basically going to give you angle at which repetition occurs. Okay, अगर मान लेते कि 2-fold, n means number of folds, ठीक है, 2-fold, तो it will be pi, that means 180. तो every 180 degree में it is going to repeat it. Okay, तो अगर मान लेते कि there is a 2-fold axis like that. Okay, तो ऐसा नहीं जाता है, ये सेंटर में जाता है. ठीक है, अगर मान लेते कि ये सेंटर में से गया है, ठीक है, फ्रॉम योर टॉप टू बॉटम. ओके, तो आपका पेज से दूसरी तरफ गया है, तो ये केसेस में क्या होगा? तो पहला ये 180 डिग्री में इट इज गोइंग टू रिपीट अगेन, तो सेम दिखेगा. then 180 rupees में 180 degree में, so it is going to give you the same. Okay, so that's why it is the two-fold axis. Okay, same thing is here also. थ्री फोल्ड में ये आपको सेम दिखेगा. ये अगर मान लेते कि यहाँ पे ऐसे रोटेट करेंगे तो थ्री फोल्ड में, तो 2 पाई डिवाइड बाई 3 कितना डिग्री में करेगा? Anybody? It will be a 120. Okay, 360 divided by 3. That means at every 120 degree, it is going to give you the same pattern. Okay, the same thing is also in case of the A4. This is your in case of the A6. Okay, and you can see also there is an example of four-fold rotation. In this case is A, and it is going to be oriented like that. ठीक है, ये केसेस में ओरिएंट हुआ, तो ये जो A था अभी, तो ये क्या दे देगा अभी? ये अभी देगा 2. क्लियर? मतलब ए अभी यहाँ चला गया है, कहाँ? ये यहाँ पे. ठीक है, so 2 is going to be created. So in this way, so after every 90 degree, the same phase is going to be find out in these cases. Okay, देखो ये वाला जो फेस है, it is similar with this one. Okay, कब ये मिलेगा? जब हम ये फेसेस को 90 डिग्री रोटेट करेंगे, तो 90 डिग्री रोटेशन, तो इट इज गोइंग टू गिव यू द सेम फेस. तो 90 डिग्री में हो रहा है, तो इसका मतलब कितना फोल्ड का होगा? तो 2 पाई डिवाइडेड बाय, हाँ 2 पाई 90 ये होगा, तो व्हाट इट विल बी? इट विल बी 4. ठीक है, 2 पाई मींस इट इज 360 डिग्री. 360 डिवाइडेड बाय 9, इट विल बी 4 फोल्ड axis of symmetry. So it be from here, what is the numerical question we can expect? So there will be numerical questions like कि ऐसे theory में लिख देगा कि at an angle of 90 degree, or you can say at an angle of 60 degree, if the plane, or you can say if the repetition of motifs by a set of uniform rotations about an axis is fixed, then what will be the fold of what is the axis of symmetry, what is the nature of the axis of symmetry, it can be asked. तो आपको क्या करना है? सिंपली ये वाला फॉर्मूला यूज करना है, 2 पाई बाय आपका कितना डिग्री में वो रिपीटेशन हो रहा है, तो बाय व्हिच इट इज गोइंग टू गिव यू द n, दैट इज योर नंबर ऑफ फोल्ड्स ऑफ एक्सिस ऑफ सिमेट्री. ठीक है, ओके. सो नाउ कम टू, एंड हियर दीस आर सम एग्जांपल्स. ओके, ये केसेस में यू कैन सी आल्सो दोस थिंग्स. दिस इज योर A2. Two-fold axis is going to be created here, and the formula, or you can say the symbol is here, it is a lens. ठीक है, it is a lens, and here it is a equilateral triangle. ठीक है, and here it is a square, that means it represent A4, and here it is represent three-fold axis of symmetry, and here it is a hexagon, and it is going to represent six-fold axis of symmetry. Okay, six-fold rotational axis of symmetry, you can also tell. Okay, so in this way the मैं इसलिए भाग रहा हूँ बिकॉज दिस इज द न्यूमेरिकल पार्ट, सो मैं ज्यादा डिटेल्स में नहीं जा रहा हूँ. ठीक है, एंड इन केस ऑफ द इन्वर्जन, व्हाट इज द थिंग दैट गोइंग टू हैपन? मैंने एक ही चीज बताया था, दैट इज जो इक्विडिस्टेंस. इक्विडिस्टेंस का मीनिंग ये है कि व्हाट हैपेंस हियर इफ यू आर गोइंग टू राइट द बी. ठीक है, एंड दैट इज द सेंटर ऑफ सिमेट्री. ठीक है, तो अभी क्या होगा? ये उल्टा हो जाएगा. Get my point? It is inverted. Okay, as per the inversion rule. ठीक है, तो what I am going to tell you that the distance from here to here, okay, and the distance from here to here, it will be equal. Okay, if this is your A and this should be A. So that is called as equidistance. मतलब there is no perpendicular distance. Perpendicular distance कौन से केस में आता है? Reflection cases में. Inversion cases में क्या होता है हमारा? Equidistance. Okay, okay. तो ये सिंपली कैसे होता है? तो सिंपली अगर हम इसको रोटेट करेंगे ना, तो ये कितने सिंपली इसको ये मतलब, हाँ नोटेशन पहले देख लेते हैं. तो नोटेशन इज गोइंग टू बी रिप्रेजेंटेड एट स्मॉल आई. ठीक है, इट इज गोइंग टू बी रिप्रेजेंटेड एट स्मॉल आई. तो प्लेन ऑफ सिमेट्री बेसिकली रिफ्लेक्ट्स. सेंटर ऑफ सिमेट्री क्या करता है? इनवर्स. ये क्या करता है? इनवर्स द ऑब्जेक्ट्स. ठीक है, ओके. Through the origin of the identical feature, you can say. Okay, anything? See, there is one thing is that so always the center of symmetry is going to be, ये अगर हम इसको ऐसे करेंगे ना, तो it will be like this. Then ये क्या हो जाएगा? it will be like this. मतलब ये मैं थोड़ा सा स्मॉल स्मॉल स्टेप पे दिखा रहा हूँ कि कैसे ये उल्टा होगा, ठीक है। ओके, नहीं यहाँ पे थोड़ा सा चेंजेस आएगा। ऐसे ऐसे उल्टा होते थे, फिर ये ऐसे मूव करके चला जाएगा। तो दैट मीन्स इट इज द इक्विवेलेंट टू A2 axis of symmetry. Remember, the I is always it is going to be the equivalent to the A2 or you can say two-fold rotational axis of symmetry. ठीक है। ओके, मतलब 180 डिग्री में सेम होता है। जैसे कि इफ यू गोइंग टू सी हियर, तो व्हाट हैपेंस हियर, इफ यू गोइंग टू सी हियर, तो व्हाट हैपेंस, दिस इज योर आई, ये फीस का कोई भी, ये जो दोनों फीसेस हैं, तो कोई भी उनका पार्ट ले लो एंड इट इज गोइंग टू क्रिएट ए इक्विवेलेंट डिस्टेंस, सॉरी इक्वी डिस्टेंस, not equivalent distance. Okay, the same thing also here, the center of symmetry is present here and here it is also the center of symmetry present. Okay, center of symmetry means three things, three things you just have to remember. First thing is that it involves the objects. Okay, second thing is that the equidistance is important, it is always going to maintain equidistance. The third thing is that the notation, that is your I. If there is any presence of I, that means the center of symmetry is present. Okay. ओके, तो फॉर्म्स केसेस में मैं थोड़ा सा सिंपली आपको बता दूं बिकॉज वी आर रनिंग आउट ऑफ टाइम। तो हाँ, तो फॉर्म्स केसेस में क्या है, तो सिंपली हम पेडियन, पिनाकल, डोम एंड स्पिनॉइड, ऑल द थिंग्स वी हैव ऑलरेडी सीन। हाँ, तो सी, तो हमने वी हैव ऑलरेडी क्लासिफाइड ऑल द थिंग्स, देयर इज 48 फॉर्म्स। Okay, and those forms are basically written here. This is the pedian, so only single plane. It is also called as, it is also called as monohedron. Okay, and the pinacoid and dome. Okay, you can see the images. That's why I have attached the images because we are not going to waste too much time here. It is called as dihedron. ठीक है, and the spinoid is here. The spinoid cases में, sorry, pinacoid is the single one. Pinacoid is not called as the dihedron. Just a second, why it is not called dihedron, I will tell you. The dome and sphenoid, these are called as dihedron. Okay, these are called as the dihedron. So why? Because it is consisting of two non-parallel faces. तो यहाँ पे non-parallel faces रहते हैं, two non-parallel faces रहते हैं. But in case of the pinacoid, it is also going to also contain two but parallel faces. Okay, remember it is called as dihedrons. The pinacoid is not called as the dihedron. ठीक है, तो पेडियम, पिनाकोइड, डोम, तो अभी तक कितना हुआ, चार. ठीक है, ओके. So now come to the prism part. तो prism cases में, now come to the prism part. तो prism part cases में, तो you can simply see and these are the cross sections. ये जो यहाँ पे लिखा हुआ है, these are your cross sections. Okay, so simple thing, rhombic, trigonal and all the things. Okay, so you can see here also from the cross sections also you can easily find out, and the symbols are here. The lens means it is the two-fold symmetry. The triangle means it is a three-fold. Okay, and this is your four-fold. Okay, so in this way you can find out all the present things. This is not important in case of numerical aspects, and these are in case of the pyramids. Okay, and there is two types of pyramids also. Here it is a rhombic pyramid, but it is not going to be here. तो rhombic ये डायपिरामिड केसेस में आएगा. ठीक है, गलती से यहाँ पे आ गया है, तो rhombic डायपिरामिड. तो डायपिरामिड मीन्स देयर इज ए मिरर प्लेन. अगर मान लो तो कि ये एक ट्राइगोनल पिरामिड है, ठीक है, एक ट्राइगोनल पिरामिड, ठीक है, ट्राइगोनल पिरामिड. तो मैंने यहाँ पे क्या किया, एक मिरर प्लेन डाल दिया यहाँ पे, मिरर प्लेन. व्हाट इज गोइंग टू बी हैपन, it is going to give you another trigonal pyramid. ठीक है, तो ये क्या बन जाएगा, it is going to be converted into trigonal dipyramid, and di means two in crystallography. ठीक है, tri means three. Okay, so in this way you can see trigonal dipyramid is here. So these are basically the game of the symmetry elements जो हमने तीन पढ़े थे ना, reflection, rotation and inversion. These are due to the different combination of the ऑपरेशंस। तो ये जो डिफरेंट कॉम्बिनेशन होती है ऑपरेशंस के वजह से ही यहाँ पे क्या होता है। तो जैसे कि अगर आप देखोगे यहाँ पे ट्राइगोनल पिरामिड, तो इसमें अगर बस एक सिंपली प्लेन ऑफ सिमेट्री ऐड कर दें तो इट इज गोइंग टू बी कन्वर्टेड इनटू ट्राइगोनल डाइपिरामिड। अगर यहाँ पे फिर भी अगर प्लेन ऑफ सिमेट्री ऐड कर दें तो इट इज गोइंग टू बी कन्वर्टेड इनटू डाई ट्राइगोनल पिरामिड सिंपली। तो यहाँ पे क्या करेंगे, ट्राइगोनल डाइपिरामिड मतलब, तो ट्राइगोनल पिरामिड केसेस में नंबर ऑफ फेसेस विल बी 3। In these cases it will be 6 because 3 ऊपर है 3 नीचे है due to the mirror plane. Okay, but in case of the right trigonal pyramid ऊपर कितने हैं 6, क्योंकि हर एक फेस के बीच में अभी और एक एक mirror planes हैं. You can see here it is another one, here it is another one, the same thing here it is another one. तो हर एक फेसेस को दो दो में डिवाइड किया गया है, तो ऊपर है 6 नीचे है 6, तो टोटल will be 12. Okay, so in this way, the complexity of the forms is going to be increased due to the addition of the symmetry of elements. Okay, okay. So that's why the cubic, why cubic is the complex, more complex, because वहाँ पे बहुत सारे symmetry elements होते हैं. Okay, if you are going to see the hex tetrahedron, यहाँ पे होगा. तो trigonal trapezoidal part is here. Trigonal trapezoidal cases में 3 forms आते हैं, total 3. Trigonal trapezoidal, tetragonal, hexagonal. ठीक है, ट्रापेजोइडल केसेस में 3 फॉर्म्स आते हैं. ओके, तो इफ यू आर गोइंग टू काउंट आल्सो यू कैन इजीली काउंट, देयर विल बी एट लास्ट इट विल गोइंग टू गिव यू द 48. स्केलेनोहेड्रन केसेस में 2 टेट्रागोनल एंड हेक्सागोनल क्रिस्टल सिस्टम में आते हैं. देयर इज 2 नंबर्स ऑफ फॉर्म्स ऑफ दिस स्केलेनोहेड्रन. ओके, एंड देन आफ्टर दैट देयर इज rhombohedron in case of the trigonal. Okay, trigonal crystal system. And if you are going to see rhombohedron cases में there will be 6 faces. ओके, एंड अब में डिस्पेनोइड भी 2 होते हैं, 2 डिस्पेनोइड्स आते हैं इन रम्बिक एंड देयर इज टेट्रागोनल. ठीक है, और डिस्पेनोइड को हम और भी बोलते हैं, इसको क्या बोलते हैं, इट इज आल्सो कॉल्ड एज टेट्राहेड्रॉन. ओके, so I have not show you the image part. The hedron means it is the face, tetra means it is 4. Okay, in crystallography hedron means face, gonal means एंगल. ठीक है, कहीं पे टेट्रागोनल लिखा हुआ है, टेट्रागोनल मींस 4 एंगल्स. ठीक है, टेट्राहेड्रॉन, हेड्रॉन मींस 4 फेसेस. हेक्साहेड्रॉन, हेक्साहेड्रॉन मींस 6 फेसेस. हेक्सागोनल मींस 6 कॉर्नर्स. ओके ओके, सो हाँ, यहाँ पे डिस्पेनोइड केसेस में एक स्पेसिफिक प्रॉपर्टीज है. तो ये इसका एवरी फेस ऑफ डिस्पेनोइड इज एन इक्विलैटरल ट्रायंगल. Equilateral triangle. Okay, so and these are the isometric forms. How many isometric forms are there? If you have remembered from the previous class, how many? 15. Okay, तो 15 से तुम्हारा 10 हो जाएगा स्पेशल. Okay, plus 5 will be your general. How many closed forms are there in case of the isometric? All. ठीक है, all are closed form. ठीक है, you can see there will be 8 and these are the 7. So these are the things you just have to remember. Okay, okay, so there is all 48 forms. 33 I have already told you, these are the non-isometric, and isometric cases में कितना होता है 15. Okay, 33, 15 and all total it will be 48. Okay, okay, so I think the time is over. In the next class we are going to cover the rotational axis and the numericals. Some numericals are there also. I have prepared in the different PDF. Due to the shortage of time, we are going to conclude the class here. In the next class, we are going to complete all the symmetry part, the point symmetry and the point group, space group, and the exponent size notations. And if possible, we are going to conclude the. No, we are going to take another classes, 2 classes. So in the next class, the advanced crystallography. In that, we are going to see the Bragg's equation and all the miscellaneous parts of the crystallography. Okay, so thank you so much guys.